Alrighty, take 100. So today we are designed to task what is called the BigEven circuit. This circuit accepts the unsigned binary output from a 10-digit keypad and will output a high value only if the input is an even number larger than 3. So we're going to be working with digits 0 through 9 as our 10 digits here. Again, anything over 3 and is even is going to be outputting a 1. So we can make a little truth table here. I have decimal numbers 0 through 15 here because we will be working with 4 bits. If we were to be working with anything less, obviously, like 3 bits, we'll only have a value up to 7, which is 8 digits, 0 through 7, so we don't want that. So let's go ahead and fill our table with our incremental binary digits going from 0 all the way to 15, okay? And for the first 4 outputs, automatically are going to be filled in with 0 because, like the problem said, we only want digits larger than 3 and are even. So filling the rest of our 10 digits here, you could see that we have 1s inputted at 4, 6, and 8. These are going to be our only even numbers that need to output a 1. Now for the rest of the digits that we have here, we're going to fill them in with an X because they are not necessarily bad for us. They're just meaningless. We're only working with 10 digits here. 0 through 9, 10 through 15 are useless, but can be useful for us if we build a K-map, which is what I have here. So let's kind of fill this K-map in. So let's start with filling in all our 1s here. We have a 1 here at 0, 1, 0, 0. You can see that A3 is our A, A2 represents B, A1 C, and A0 D. Here's our A, B, C, D. And what we want to see is where we have a 1 at 0, 1, 0, 0. So A is 0, B is 1, C is 0, D is 0. That represents 0, 1 here and 0, 0. So it's going to be this square here. So filling that in, you could see we have a 1 here. Now we also have a 1 at 0, 1, 1, 0. That's here, 0, 1, 1, 0. And finally we have 1, 0, 0, 0. 1, 0, 0, 0. So next we could fill in all of our X's here. This is where they come to use. Works just like 1s, 1, 0, 1, 0. We have 1, 0, 1, 0 X here, and all the rest get filled in. And once we have this, what we want to do is we want to start grouping all our 1s into some group that is to the power of 2, speaking about area. So 2, 4, 8 blocks, all perfectly fine. We couldn't do 6 blocks, for example. We couldn't do 3 blocks, but 2 is fine. And looking at this, we want to avoid all zeros as well, and every blank square here represents 0. So we couldn't say have a box here because there would be a 0 in that box. And filling this out, I found that the simplest solution is that we have to include all the 1s and that. Here all the 1s are included, the X's don't matter, that's why they're useful to us. So once we have our circles here, we could come up with a logic equation. And how that's going to be outputted is we have, let's see here, in this circle, we have 1, 1 here, a matching number under B, 1, 1. I'll go ahead and reveal the answer. So we input B here. C prime, so this is where we have C and D both in the 0 here collectively. That gets complemented, C prime and D prime. Let's move on to another example, A, C prime, D prime. So that is this circle here. We have we have A being filled in because it's 1, 1, and it's both being shared in these 2 boxes here. So, and that does not get complemented. C prime and D prime do, again, because they are zeros matching in these 2. and the B, C, and D prime being ANDed together are here. Okay. So now that we had the equation as a result, we could simplify. I saw that there's a B and a D prime and a B and a D prime here. I decided to merge these together and get those C primes and C, which is equal to 1. And that simplifies to the final form here. B ANDed with D prime, which is ORed with A, C prime, D prime all being ANDed together. So now we can build our circuit in Logisim. So I'll go ahead and open up Logisim here. And what we want to go ahead and start doing is finding our gates. In fact, I think I have a screenshot. So this is our equation here. I'm going to leave that to the side here because it's useful. We have an AND gate, an OR gate, and some NOT gates that we're going to use. So let's go ahead and set up some AND gates first. I'll place one here. I'm going to make this one have 3 inputs. That's going to be for the A, C prime, D prime. I'm also going to add another here, leave that with 2. Let's go ahead and add some inputs. We'll have our A input here. We'll have our B input here. We'll have our C input here. And then finally our D. Great. So looks like everything at the end gets ORed together. So we'll have one OR gate. And then finally, or I should not say finally, we'll have an output here. And then we're going to have some NOT gates. It looks like D prime and C prime are the only ones that get knotted. So I'm going to leave it right in front of them. Another one here. So now we can finally start building everything together. So this B being ANDed with D prime, we can go ahead and put that together. So we'll get our D knotted and then put that, into this input here. And that's our B. We'll put that into here. Great. And now we have our A, C prime, and D prime being all added together. So we'll have our C prime going here. We'll take our D output, knotted, I should say, into there. And then A goes into here. From there, everything gets ORed together. So we throw both of these outputs of these AND gates into this OR gate. And then that ends up going into our output, Q. So I'll go ahead, select this, and name it Q. So everything can be accessed here, these gates, through the library. You can also find some TTL chips here, which are also representing gates. You could play around with those as well. So I'm going to go ahead and select the poke tool. And what this poke tool does is if you could click on any wire, it will show either voltage or current, whatever you have it set to, or it can manipulate these numbers here. So we can start, again, we should have 8, 6, and 4 being our only outputs, our only 1 outputs. So we'll go ahead and start with 0. We can have a 0. We'll move to a 1. We also have a 0. We'll have a 2, output 0. We'll have a 3, output 0, as should be. Now 4 should be our first output of 1, and it is. So we'll go up to 5, it's a 0. We'll go up to 6, it's a 1. That's another one that we should have output as 1. 7 should be a 0, and then finally our last output should be of 1 should be 8, which it is. So, and then we'll go to 9 for our final 10th digit, and we have an output of 0. And then anything above that, of course, should output 0. So there we go. That's everything in order. Thank you for watching.